Okay, we're ready for part 2 of Rational Inequalities worksheet. This will be problems 9 through 17. When we start with an example of problem 9, you'll notice that it's game time ready already. You will see that 0 and 5 are disallowed in the denominator, and 3 and -4 are okay for the numerator. You'll also see that we're just looking for 0 and positive. Now, I want to remind you that remember when we have a negative even number of times we get a positive, but when we have a negative an odd number of times we get a negative. So it didn't matter if it was x minus 5 to the first, to the third, to the fifth, to the seventh, etc. It still says to the left it's negative and the right it's positive, like the other three of these will be. So I set up my plus, plus, minus, minus chart. Again, be sure you put your numbers in number line order. -4, then 0, then 3, then 5, not the order that you factor. And so I put in my zeros, my negatives, and positives. I found my product, and I found that I'm positive and negative and positive and negative and positive. But now I'm looking for the positives. So I put in the open circles on 0 and 5, closed circles on the 3 and -4. And I shaded what was needed. Notice we have a left end, we have a right end, and we have a middle. Now, we can, of course, write this the normal way like we would be used to. On top, x is less than or equal to -4. X is between 0 and 3, including 3. X is greater than 5. Or we can go ahead and put the negative and positive infinity on and set these two up alike. Only here we're using x and here interval notation. Here, of course, looks the same, and over here it would match this with interval notation. All right, problem 10. It would be ready to go, but we need to factor it, so it will be game time form. So I went ahead and factored it, but what did I notice? I noticed x minus 3 is on top and bottom. What does that tell me? It tells me that when I reduce these, I'm going to get a whole, since they're both in the numerator and the denominator. So note x can't be 3 since it's in the denominator. And notice whenever you're top and bottom and you cancel it, I don't call it a vertical asymptote, but we know it's going to be a whole instead from what we've done earlier before and during spring break. So I went ahead and reduced it, and my x is less than or equal to 0, so I'm looking for 0 and negative, but I can't throw away the fact I have a whole, because remember, a whole means you have to be an open circle. So I have x can't be -4 open circle. It's factored. I don't see it anymore, but I have x equals 3. It's got to stay there. X equals -2 is in the numerator only, so it's 0. So when I put my chart and I put the numbers in number line order, -2, then 3, then 4, -2 is the only one that's closed. Now, what else is unique about this? Look at this. How many times do I actually have x minus 3? Doesn't matter if you're multiplying or dividing. I have it twice. And what do we know negative times negative is positive. Positive times positive is positive. That is, if we see an even number of negatives, we're going to be positive, and so we have to be careful of this evil problem, because when I do the -3, it's going to be pluses all the way across because of the fact that there's two of them. So now my little chart down here looks weird, like some of those plus, plus, minus, minus charts we did earlier. -2, again, is the only one we can have, but it goes plus, minus, minus, plus. And of course, I'm looking for the minus. And since I'm looking for the minus, I could do this. I could say, oh, I want from, including -2 to 4, but not 3. That would be okay, but if we did it the proper way, negative 2 is less than or equal to x is less than 3, or 3 is less than or equal to x, which is 4, which would match our interval notation. Problem number 11. Here we go. We have to have everything on the left side, so I'm going to have to do my additive inverse and get things to the left. So I'm going to add negative 3 over x plus 2 to both sides. My LCD I need to find is x minus 6, x plus 6. I just rewrote the problem so it would be more clear. You could see it more clearly when I play what's missing. And of course, as always, we don't care about the crazy 0, because when you multiply something by 0, it stays the same. So I went ahead and distributed. I combined terms in my numerator. Now I could leave it 2x plus 28, or I could factor it as 2x plus 14. It doesn't change anything from me stating that the numerator, negative 14, makes it 0. That factor or not factor is your decision. The denominator, I can't have 6 and negative 7. Again, be sure you put things in number line order. Negative 14, then negative 7, then 6. Play your game. Negative 14 is the only one that's solid. We've done things like this, so I want it a squeeze play and a right end. And so I've written it in the standard notations. This is old school notation. This is the new weird notation that lets us match our interval notation. Problem number 12 is another gee whiz, what were you thinking problem. Notice, if I can get out of the sunlight, both of these are x minus 3. I'm going to do the additive inverse and move everything to the left side. Notice when I combine these, wow, x minus 3 over x minus 3 cancels. And so I really have 1 plus a third is greater than 0. And this is always true, always, always, always. But I've got to remember, since this is on the top and on the bottom, because x can't be 3 because it's in the denominator, but it's not a vertical asymptote, it's a whole because it's in the numerator and in the denominator. So yes, I'm done. My answer, short way, is x not equal to 3, or I can use the notation with inequalities, x less than negative 3, x greater than negative 3. I can add in the parenthesis stuff. Let me block the light as best I can. And then there's my interval notation. But yes, what if you just automatically went in and started playing what's missing? The key does, just because I knew a lot of you would, so I'm laughing out loud about that. So I'm going to go ahead and do the x minus 3's. I go through. Notice when I factor, I'm going to cancel the x minus 3's eventually. It's still a whole. 4/3 is still greater than 0. And the previous answer written in this form, or over here, where you have to at least write this for me, is going to still be the same. Now we're going to move into our last 5 examples, and they're going to deal with finding the domain. And so we're going to be asking to find the domain of these problems, and the information will be similar from 1 to 12. So if I ask you about the square root of a numerator over a denominator, that means the numerator of the denominator must be positive or 0. We know a numerator can equal 0, but a denominator can't, and that's always true. So when I give you this first problem and I say find the domain, I went ahead and just wrote it as greater than or equal to 0. Of course, I had to factor it. I had to realize that greater than 0 means 0 and positive. I knew that 3 and negative 3 were open circles, but 0's in the numerator only, so it can be a closed circle. I did my standard chart, and this is very similar to number 11. I'm going to have the middle and the right end. And so I have negative 3 is less than or equal to is less than x is less than or equal to 0, or x is greater than 0, or you can do the infinity form, but you must do the parenthesis negative 3 comma 0 square bracket union parenthesis 3 plus infinity parenthesis. Now, we still have a few more to do. I'm going to head to the dining room for those. Little tour here. And so now, we are ready. And so I give you another problem, and of course we're up to find the domain, but now we're being sneaky. Notice it's 2 minus x, and you always want your x positive, so I factored out the negative, but now I've got a crazy negative sign on that side, so I'm going to want to multiply both sides by -1, but oh, here's the catch. Here's what's going to kill you. What happens when you negate the left and negate the right? You must also negate the inequality symbol. So when I write it as x minus 4 over x minus 3, it's now x is less than or equal to 0. And so now I don't want 0 in the positives, but 0 in the negatives. My chart is as my chart always is. But now since I'm looking for the negatives, I'm going to want the middle and not the ends. And so my domain is 2 is less than or equal to 4 is less than or equal to x. Here's the cousin problem. Hello, cousin. Because notice where's the negative this time? It's in the numerator. I want to find the domain. I set it up as numerator over denominator greater than or equal to 0. But notice if I negate the top, I have a negative sign here. And so I'm going to negate both sides. But when I negate both sides or multiply by -1, I must reverse my inequality symbol. I know that -1 does not exist, but 4 can because it's in the numerator. I make my chart. -1 open, 4 closed. Turns out that I'm looking for the negative, so I want the middle. So my answer is -1 is less than x is less than or equal to 4. Or in interval notation, parenthesis -1, comma 4, close bracket. 2 more examples. They're no fixing up. It's just that you're going to see you're not always the middle. So here it looks pretty normal. I ask you to find the domain. I'm not going to have to reverse my inequality symbol. I just want 0 and positive. 6 is out and -2 is in. I make sure I have them in the proper number line order. -2 is closed. 6 is open. I'm looking for positives. The product is positive and positive here. And so I've got the 3 ways to write it, of which you need to write the bottom one in either way 1 or way 2. You can write all 3. As always, I'm never upset when you show me that you understand more. So f of x is equal to the square root of x minus 3 over x squared minus 4. Again, find the domain. Again, it's ready to go, except I need to factor. So I factor. All coefficients of variables are positive. So I stay 0 and positive. I can't make the denominator 2 or -2, so those are open. But the 3 is okay, and so it's closed. And again, I just complete my chart with its negative and positives because there was nothing tricky here. Each factor appeared just once, which is an odd number of times. So I'm going to get the standard 3 answers. Again, I need 1 or 2, but I do need this one for all of them, so I need at least 2 of the 3 or all of the 3. And so now you are able to finish the rational inequality worksheet.